This test passes. It passed 100 times in a row. It passed in code review. It passed in CI. It passed on your machine. And then, in production, it failed. Welcome to the race condition. You have felt this bug. You type in a search box. Results flash in. But they are the results for what you typed 2 keystrokes ago. Somewhere, 2 async calls came back in the wrong order. It is not random. It is timing. And timing is exactly what our tests never check. To catch it, we need a different kind of test. Most tests are example-based. For this input, expect this output. You pick the cases. So the bugs hide in the cases you never imagine. Property-based testing flips that. Instead of examples, you describe a rule that must hold for all inputs. Then a library, fastcheck, generates 100 inputs per run, trying to break your rule. When it finds a breaking case, it shrinks it. It strips the input down to the smallest, simplest version that still fails. Think of it as a robot that rattles every door, and when one opens, hands you the shortest path to it. Now, the myth race conditions can't happen in JavaScript because JavaScript is single-threaded. That is half true. There is one thread, but it is concurrent. The moment you await something, you hand control back to the event loop, and other work runs in the gap. So when 2 async operations are in flight, the order they finish in is not guaranteed. If your code's correctness depends on that order, you have a race condition, single thread or not. Here's why our tests stay green. In a test, when you resolve a promise, it resolves in a fixed, predictable order. The nice order. Every run exercises the exact same timeline. The happy one. To catch the bug by hand, you would have to orchestrate every adversarial ordering yourself. Await these in this sequence, those in that sequence. And you would never enumerate them all. The bug lives in an ordering you didn't think to write. So the question becomes, what if the test could explore the orderings for us? Let's make it concrete with the example from the fastcheck docs. We have a helper called queue. You give it an async function, and queue promises to serialize the calls. Only one runs at a time, and the results come back in the order you called them. Here is the obvious test. We queue up call 1 and call 2, wait for both with promise.all, and assert we saw 1, then 2. Run it. Green. But watch. This test only ever proves that the JavaScript event loop hands back promises in creation order. It never reorders anything. It has tested the runtime, not our queue. This is where fastcheck does something magical. It gives you a scheduler. Call fc.scheduler. Think of it as a puppet master over time. You wrap your async function with s.scheduleFunction. Now, when your code calls it, the real call still fires, but the promise it returns is frozen. It will not resolve until the scheduler decides to release it. And because this runs inside a property, fastcheck picks the release order at random, 100 different ways. Suddenly, your test isn't replaying one timeline. It's replaying hundreds, including the nasty ones. Let's rebuild the test with it. We open with fc.assert around an async property. And the property takes a scheduler, s. We build our queue around the scheduled function. We fire call 1 and call 2, collecting the results as before. But instead of promise.all, we hand the whole thing to s.waiter. That tells the scheduler run everything, in whatever order you like, until these promises settle. Waiter is the flexible one. It's happy, even if the calls aren't fired all at once. Now, the same assertion, we saw 1, then 2, is tested against every ordering fastcheck can dream up. But 2 calls is still a number we picked. Real code doesn't fire exactly 2, so we let fastcheck choose. We generate a count with an arbitrary, say fc.integer, and loop that many queued calls, pushing each promise into a list, then wait for all of them. Now every run varies both the number of calls and the order they resolve. We've stopped handpicking the scenario. The test is exploring a space we could never type out by hand. There's a subtler case. So far we fire every call in one synchronous burst, but real systems fire calls in waves. A batch, then later, another batch, on top of the first. To model that, fastcheck gives us S-batch sequence. You hand it a list of steps and it runs them strictly in order. A step never starts before the one before it has finished. Though the scheduler can still slip delays and other work in between. So we generate several batch sizes, an array of integers instead of one, and fire each batch as a step in the sequence. Now we're catching bugs that only appear when a second wave arrives while the first is still draining. And yet, every test so far has a blind spot. Reread the spec. Concurrent calls are not allowed. A call must wait for the previous one to finish before it fires. We've been checking that results come back in order, but never that two calls weren't running at the same time. A broken queue could overlap calls and still, by luck, return them in order. So we add the missing check. Wrap the scheduled function. Flip a flag to true when a call starts, back to false when it resolves. And if the flag is already true, when a new call begins, fail immediately. That's the overlap. Caught red-handed. This is the test that actually pins the specification down. Here's the reward. When fastcheck finds an ordering that breaks the flag, it doesn't dump a chaotic mess of 40 interleaved calls on you. It shrinks. It peels away everything that doesn't matter until you're left with the minimal reproduction, often just two calls in one specific order, that overlap. That's the difference between a bug report you dread and one you can fix before lunch. The failing case is handed to you already reduced to its essence. Step back. Nothing here was about queue specifically. Anytime your code takes an async function as input, a fetch, a database read, a callback, you can wrap it in a scheduler and let fastcheck hunt the orderings for you. That autocomplete bug from the start? Same technique. React state updates racing? Same technique. Two writes to the same cache? Same technique. Property-based testing doesn't replace your example tests. It stands beside them and covers the timelines you'd never think to write. So here's the one thing to remember. A race condition isn't bad luck you retry until it goes away. It's an ordering your test never explored. Give the test control of time, and you can explore them on purpose. This week, take one async function you don't fully trust, wrap it in fc.scheduler, and let it try. I'd bet it finds an ordering you never tested. Go break your own code before production does.